Today I want to talk about this problem. X, Y are independent geometric random variables, and P equals to X equals to K equals P times Q to the power of K, and Y equals to M is this K M from 0 to infinity. And question, we make Z equals to X plus Y and Z equals to X minus Y, and we can find the PMF of Z. First, let's do the first part, that is Z equals to X plus Y. The probability of Z equals to N equals to P X plus Y equals to N equals to P sigma K P equals to X equals to K Y equals to N minus K. This is K from 0 to N, P X equals to K, Y equals to N minus K. Since they are independent geometric random variables, we can take this one, P X equals to K times P Y equals to N minus K. And so we can write K from 0 to N, P, this is P times Q to the power of K, and this is P times Q to the power of N minus K. So this is P squared Q to the power of N, sigma from K from N, 0 to N. So this one is N minus 1 times Q times P squared Q to the power of N. This N from 0, 1 to infinity. Let's do the second part. Z equals to X minus Y. Case 1. We can make this. When Z greater than 0, that is X greater than Y. Thus, for M greater than 0, T Z equals to M equals to P X minus Y equals to M equals to sigma K from 0 to infinity, P X equals to M plus K, Y equals to K. We can take, since they are independent, we can get P X equals to M plus K times P Y equals to K. And this is K from 0 to infinity, P times Q to the power of N plus K times P to the power of K. This is sigma K from 0 to infinity, P squared Q N plus 2K. This is P squared Q to the power of M sigma K equals to 0 to infinity Q of 2K. And this one we can write P squared Q to the power of M times 1 minus Q squared. This is because P equals to 1 minus Q, so we can write 1 plus Q P to the power of Q of M, and M equals to 0, 1, 2. For case 2, when when Z smaller than 0, that is X smaller than Y, for M smaller than P, Z equals to N, equals to P, X minus Y equals to M. This is sigma K, P, X equals to K, Y equals to K minus M. This is K from 0 to infinity, P, X equals to K times P, Y equals to K minus M. Since they are independent, then we can get from K from 0 to infinity times P, Q to the power K times P to the power K minus M. This is P squared Q sigma K from 0 to infinity Q 2K minus M. This is P squared Q 2K sigma K from 0 to infinity. So this is P squared Q minus M times sigma K from 0 to infinity Q 2K. This is P squared Q minus M 1 minus Q squared. Because P equals to 1 minus Q, we can write 1 plus Q, Q minus M. M equals to minus 1 minus 2 to minus infinity. Combine this case 1 and 2, 1 and 2, case 1 and 2, we can get P Z equals to M equals to P times Q to the power of absolute value of M of 1 minus Q or 1 plus Q. M equals to 0 plus and then minus 1 plus minus 2 to infinity.